Hello and welcome back. In last video, we have discussed some circle terms and symmetric properties of circle. In this video, we are going to discuss some questions which involve the symmetric properties of circle. So if you haven't watched the previous video, do not jump into it directly. So let us start this video. So these are some selective questions from exercise 9A of book 4, and the first question, it states in the figure below JK is chord of the circle with center O. We can see a circle over here, its center is marked O and JK is over here, it is a chord of that circle. Point Q lies on the JK such that JQ equals QK, which means these two parts are equal. That actually means that OQ is passing through the midpoint of that chord. Then it states, given that the radius of circle is 16 centimeter and OQ is equal to 7 centimeter. We can see OQ over here, that is basically a line segment that passes through the midpoint of the chord, and radius of the circle, it can be marked over here because radius is the distance or the line segment that joins circles center of the circle to any point on the circumference. So it is 16, so it will become 16 centimeter over here, and we have to figure out the length of the chord JK, and we can see that chord JK is divided into two segments, JQ and QK, and both are equal. So according to the first property, as OQ is passing through the midpoint of the chord, so it must also be perpendicular to this chord. So here it creates a right triangle, and we are going to find the value of QK from that right triangle using the Pythagorean identity, because there are two known sides and we can find the third side. So it shall become over here here is the point O, here is point Q, and here is point K. We know OK is equal to 16 centimeters. OQ is 7 centimeters. So using the Pythagorean identity, it shall become QK square plus 7 square equals 16 square. And because we have to figure out the value of QK, so we will move 7 square to the right hand side. So QK square shall equal 16 square minus 7 square, and in order to find the value of QK, we will square root both sides, and using calculator the value of QK shall become 14.39, or if we want to keep it in third form, it is 3 times the square root of 23. So that is the value of QK, as we have to figure out the value of chord JK, which is basically double of this. So it shall become the length of chord JK equals 2 times 14.39, or I can also say that it is 2 times the square root of 2 times 3 into square root of 23. So the answer to this becomes 28.78, or if we want to keep the answer inside, it will be 6 times the square root of 23. So that is the value of chord JK. So that was the first question. Now let us jump to the next question. It states, given that O is the center of each of the following circles, find the values of the unknown. So we can see a circle over here. Here is the center O, and here is a chord which is not named. Like I will like to name it first, that this chord is PQ. PQ are the endpoints of the chord, and the point of intersection of the line segment from the center, it meets the chord at point M, suppose. So we have a circle with center O, and the distance between the center and chord is 5 centimeter as it is given over here, and we can see the radius of the circle is given 13 centimeter, it is marked over here. So in order to find the value of A, we can see that both sides equal a using this symbol. So basically OM is passing through the midpoint of the uh, chord PQ, and if it is passing to the midpoint of the chord PQ, it is also perpendicular to that chord. So it creates a right triangle over here. Here is point M, here is point O, and this is point Q over here. We know OQ is 13 centimeter because that is the radius of circle. The distance between O and M is given 5 centimeters. So we can figure out the value of A, which is base of that triangle. It will become A square plus 5 square equals 13 square. So A square shall equal 13 square minus 5 square, and when we square root both sides, that shall become 12 centimeters. So the value of A is 12 centimeter. Now coming to second part, we have to find the angle B as well. Angle B is marked over here, and as we have all three sides of this triangle, in order to find the angle over here, we can use any of the three trigonometric ratios. We can use sine or cosine or tangent. So I'm going to use the tangent ratio. It will become tangent B. You know, tangent of an angle is ratio of side opposite to that angle, which is 12, to the side adjacent to that angle, and that is 5. So angle B shall become tangent inverse of 12 upon 5, and with the help of calculator we can figure out the value of B, which becomes 67.38. So that is the value of B over here. So these were the two unknowns in first part, the part A. Now we move to part B. Now here is part B, where we can see O is the center of the circle and there are two chords. One is 26 meters while other is 16 meters. And first let me name these chords, like this chord is XY and the second chord is PQ. And we can see that there is a line segment that is perpendicular to the chord passing to the center, and we know from the first property that if it is perpendicular to the chord, it will also bisect the chord. So if it was 26 meters, then it shall become the segment of 13 meters, 13 meters and 13 meters over here. Now we see the radius of the circle, which is given over here, it is 17 meters, so I can also extend it to this side, the distance between the center and point Y. So here it creates a right triangle. Here is the center O. I will name this point as M. Here is a right angle at M and this point is Y. The unknown C is over here, while we know here is 17 meters and it is 13 meters over here. So using the Pythagorean identity again, it will become C square plus 13 square is equal to 17 square, and C square shall become 17 square minus 13 square, which we solve by taking the square root on both sides, and the value of C shall become 10.95 meters by using a calculator. So that is the value of C. Now we see here is an angle D. So first we will draw a line perpendicular to this chord PQ, and we know as it is a perpendicular line, it will also pass through the midpoint of the circle, midpoint of the chord, and it creates a right triangle over here. Here is the right angle, and this side over here will be half the 16. It will be 8 meters, and here is 17 meters, and here is the unknown angle D. So we can see we can use trigonometric ratio cosine, because we have a side adjacent to that angle 8 meters, and we have the hypotenuse of that triangle. So using cosine d, it shall become 8 upon 17, and because we have to figure out the value of angle d, it will become cos inverse of 8 upon 17. So cosine shall become, so d shall become 61.992 degrees. So that is the value of d. So these were the two unknowns in this triangle C and D. Now we move to the part C. In part C, we can again see there is a circle with center at O, and there are two chords, one with the 10 millimeter length and other with 12 millimeter length. And here is the distance between the center and the chord of 12 millimeter. It is 5 millimeters, and the distance between center and 10 millimeter chord, it is E, which is unknown. And here is the angle between the radial segment and the chord of length 10 millimeter. These are the two unknowns. So first of all, in order to figure out the value of E, because we know there are two chords, I will like to name it as AB and CD. So we know OC must equal OA because both are the radial segments, and here we can see that angle is 90 degrees, so it is also passing through the midpoint of this chord. So this side shall become 6 millimeters. So we can find the value of OC using the Pythagorean theorem. OC square shall become 6 square plus 5 square, because OC is the hypotenuse of that triangle. So OC square shall become 36 plus 25, and that equals 61. So the square of OC equals 61. We know OC square will also equal OA square, and OA square is also the hypotenuse of a triangle with one side E millimeters and other as 5, because we know here is a right angle, so it will also be passing to the midpoint of that triangle. So here it is a triangle with the given sides. This side is E, this side is 5 millimeter, while here it is the square root of 61, because OC square was 61, so OC will be 61 square. So we can again use the Pythagorean identity because it is a right angle triangle. So it will become E square plus 5 square, it equal to 61 square root squared, and we know it will cancel the square root. So E square shall become 61 minus 25, which is definitely 36. So E is 6 millimeters. So that is the value of E. And now coming to the value of angle F, we know angle F is over here, and we have all three sides. We have the hypotenuse 61 square root, we have its adjacent which is 5, we have its opposite E which is 6. So we can use any of the three trigonometric issues. I am going to use the tangent. So tangent F shall become 6 upon 5. 6 is the side opposite to that angle and 5 is the side adjacent to that angle. So F shall become tangent inverse of 6 upon 5, and using the calculator we will figure out its value, which is 50.19 degree. So that was the C part. Now let's move forward. So in this question number 11, it states in the figure below, O is the center of the circle. So we can see O is over here. This is the center of the circle passing to the points A and B. TA is the tangent to the circle at A. We can see TA is over here and it is tangent to the circle at point A. And the first thing that comes to our mind is that a radial segment is perpendicular to the tangent at point of tangency. So that is one of the symmetric properties. Now it states TOB is a straight line. The TOB line is over here, and given that AOT is equal to 64, which is marked over here 64 degrees, find angle ATB and TAB. So in order to find the angle ATB first, we know ATB angle lie over here, and this is a right triangle with the acute angle 64. So we will directly subtract the sum of two angles 90 and 64 from 180, because the sum of the all angles of a triangle is 180. So it will be 180 minus 90 plus 64. And when we subtract the sum from 180, it shall become 26 degrees. So the angle ATB becomes 26 degrees. Now coming to the second part, angle TAB. First, let me clean some area. Angle TAB actually lie over here. We know it is basically sum of these two angles. One angle is 90, we know, and the other part of the angle, this lie in the triangle OAB. We can draw the triangle OAB again over here. Like this is OA, here is the side OB and the side joining O, A and B. So this is the point O. We know the angle over here because we need this angle as well. It is 64 degrees, and we need to figure out this angle at point A. Now we know OA and OB both are radial segments. So this is an isosceles triangle, and in isosceles triangle, the two angles opposite to two equal sides are equal. So if I mark this angle as x, this angle will also be x. So in order to find this angle x, we can use the triangle property that exterior angle of a triangle equals the sum of opposite interior angles. Like we see the exterior angle over here, it is 64 degrees, and it shall equal the sum of opposite interior angles, and both are x. So it will become x plus x equal to 64 degrees, and we know that if it is 2x which equals 64, then x must be half the 64, which is 32. So this angle over here becomes 32 degrees. So the angle we required, the angle TAB, is sum of the angle 90 and 32. TAB equals 90 plus 32, and that is 122 degrees. So that was one question. Let's move to the next one. Now here is the question 13. It states, given that PA and PB are tangents to each of the following circles with center O, find the values of the unknown. So here is A part, where we see O is the center of the circle, PA and PB, which are over here, they are tangents to the circle at point A and B respectively. So because they are tangents to the circle, we know they will be perpendicular at the point of tangency, the right angle at point B, and there is a right angle at point A definitely. Now, in order to find the value of A, because we know angle A is over here, according to one of the symmetric properties, we know the line segment joining center with the point of uh, intersection of tangent, it basically bisects the angle over here. So if it is 49 over here, the angle A is also 49, and that is directly from the symmetric properties. Now the second thing that we have to find the value of side B centimeters, and we know the lengths of two intersecting tangents are equal. We can see the length of tangent PA, it is 14 centimeters. So length of tangent PB will also be 14 centimeter, because they intersect at point P, and the lengths of two intersecting tangents are always equal. So B is directly 14 centimeter. Okay, first thing, that the line segment that joins center with the point of intersection of tangents, it bisects the angle at the center as well as the angle over here at the point of intersection. So now moving to B part. In B part, we are to find the value of one angle C over here and the length of tangent PA, which is marked as D. So in order to find the value of C, we know these are two tangents, so the angle over here is 90 and angle over here is also 90. So first, because the line joining the center with point of intersection of tangents, it uh, bisects the angle over here. So if it is 32 degree, then the angle below it should also be 32 degrees. Now here is a triangle OAP and we need to figure out the value of C. So it will be simply 180 minus the sum of other two angles 90 and 32. So after we subtract it, it shall become 58 degrees. Now, in order to find the value of D, we know value of D is basically length of tangent AP and the length of tangent PB is 15 centimeter, and definitely they are equal because lengths of two intersecting tangents are always equal. So C is 58 while D is 15 centimeter. Moving to the next part. It is over here. A circle with center O, the distance between the radial segment over here, it is 10 meters. We are to figure out the angle E over here and the value of side F, which is basically length of tangent uh, PB. Now, because we know angle at center, it is 112 degrees complete angle. So the angle over here, it will be half that. It will be 112 divided by 2, and that is 56 degrees. So angle over here is 56 degrees. We know it is a right angle over here. So E will be definitely 180 minus 90 plus 56, and that shall become 34 degrees. So the value of E is 34 degrees. Now in order to find the value of F, because we know it is a right triangle over here and AP is also F and it is 10 meters over here, OA is the radial segment as well. So we can apply the tangent ratio. It will become tangent 56 equals the side opposite to it, which is F, divided by the side adjacent to it, which is 10. So F shall become 10 times tangent 56, and that after calculation shall become 13.76. It is in meters. So these were the two unknown in this part, E and F. Now coming to the D part. So in D part, we again have a circle with center O and two intersecting tangents PA and PB. And here is an angle 35 degree, while we are to figure out the two angles H and G. So first we can see that angle over here is 35. So angle adjacent to it, that will also be 35 degree. So in this triangle, uh, the triangle PAB, we can see the angle at point P, it is 70 degrees, and because we know PB and PA are equal, being the length of two tangents, so these two angles will also equal. This is H, so the angle over here will also be H. So we can find the value of H by we know the sum of all angles of a triangle is 180. So it will be h plus 70, which equals 180, which actually means that 2h is equal to 180 minus 70, becoming 110 degrees. So h shall become 55 degrees. So the value of h over here, it is 55 degrees. So if the angle over here it is 55 degrees, we know the total angle at position B, it was 90 degree. So basically it is G plus 55, which is 90 degree. If G plus 55 is 90 degree, then definitely G equals 90 minus 55, which is 35. So these are the two values of angle H and G, and in this part we can use many other techniques as well in order to find the value of G and H. Now coming to the last part, sorry, it is not last, E part. Here is again a circle with center O and two tangents PA and PB, and here are the two unknowns J and I, which is basically the distance over here. I is only this distance. So we know the radius is 5 meter. So we can say that the side over here, it is also 5 meters, and this is a right triangle being the angle uh, between a radial segment and a tangent. So in this right triangle, here are the three sides, like it is 5 meter, then it is 12 meter, and the side opposite to right angle, it is 5 plus I. So I can use the Pythagorean identity, and that shall become 5 plus I whole square equals 5 square plus 12 square. So 5 square is 25, while 12 square is 144. So 25 plus 144, that equals 169. So 5 plus I whole square equals 169. So if I square root both sides, it shall become 5 plus I equals 13. It cannot be negative because that is definitely sum of two sides, so it cannot be negative. So I will become 13 minus 5, which is definitely 8. So the value of I is 8. Now, in order to find the angle J, we can use the tangent ratio because we have the side adjacent to it and the side opposite to it. So it will be tangent J equals 12 upon 5. So J shall become tangent inverse of 12 upon 5, and that is we use calculator to figure out this value, and that becomes 67.38 degrees. So these were the two unknowns in part E. Now we move to the last part. This is the last F part. It states there is a again circle with center at O. There are two tangents. The length of tangent is 15 centimeter. The distance between the circumference and the point of intersection of tangents, this is 7 centimeters. We can see over here. And radius of the circle is K, while we are to figure out the angle between the uh, radial segment and the line joining center and the point of intersection of tangents as well. So in order to figure out the value of K first, we will again use the Pythagorean theorem. I will mark the triangle over here. This is a right triangle. We know the angle over here, it is a right angle. This is side K, this is side 15, and the side over here, the hypotenuse of this shall become K plus 7 because we know the radius of the circle is K. So it will be K over here. So the whole side is K plus 7. Again, we have to use the Pythagorean identity. So it shall become K plus 7 whole square, which equals K square plus 15 square. So first, because we can see the unknown on both sides, so we must expand the K plus 7 whole square. So it shall become K square plus 14K plus 49. It equals k square plus 15 square, which is 225. So k square plus 14k minus k square, we moved k square on the right to the left, and 49 which was on the left to the right hand side. 225 minus 49. So k square is cancelled out, and 14k is 225 minus 49, which is 276. So if I divide 14 on both sides, it shall become k is equal to 12.57. We figured out with the help of a calculator, and that is in centimeters. So that was the value of k. Now in order to find the value of L over here, we can again use the tangent ratio, because we have figured out the value of adjacent. It is 12.57. So it will be tangent L equals 15 divided by 12.57, and the angle L will be tangent inverse of 15 upon 12.57, and the ratio, the value of angle L will become 50.04. So these were the two unknown in this last part. So we